But we're going to finish example 1, so I'm just going to reiterate what it was. So example 1, suppose 2,000 is invested in an account earning 3% annual interest compounded monthly. So n will equal 12 because it'll happen 12 times a year. We use our formula we just learned. The amount is equal to 2,000 times 1 plus 0.03, changing our rate to a decimal, divided by 12, the number of compoundings, to the power of 12 times 6. So experiment with your calculator. Make sure you can get this correct answer, which I've rounded the 0.896 to 0.90 so that I have dollars and cents. Okay, the next question was, how long will it take for the account to reach 3,500? So this time we're solving for an exponent, which means we need to use a logarithm to solve for a variable in the exponent. Okay, so our first step is to isolate the exponential. So to do that, we need to divide by the 2,000, which is keeping the exponential part of this from being by itself. Divide both sides by 2,000. That will give us 1.75 equals 1.0025 times, or to the 12t power. So this 1.0025 came from simplifying this. That's not a necessary step. Sometimes it doesn't come out pretty like this, but it is something you can do at this point if you would like to. Okay, next we are going to take the log or the natural log of both sides. We always want to use the natural log when we're dealing with e, but in this case, base 10 logarithm is also fine. It really doesn't matter. I'm going to go ahead and do the log of each side, so I just write that in there. Okay, next step is to use the power property so that the exponent becomes the coefficient. So we're going to go ahead and move the 12t out to the front. So instead of, I've got a little typo right there. Uh-oh, when I hit undo again, it's going to change that. So just be aware that that should be 1.0025. I messed that up. So then step 4 is to solve for t and calculate using a calculator. So I'm going to rewrite this. Remember that was 1.0025, not 25. Dividing by 12 and by log of 1.0025 on both sides. So t equals this, which is this side of the problem here. Put it in a calculator and I get 18.677, which I've chosen to round to approximately 19 years. Okay, so just fixing my one little mistake before I post this on Canvas. So that was supposed to have been 1.0025. Okay, let's go ahead and do question 3. How long will it take the money in the account to double in value? So if we start with $2,000, doubling it means it's going to be 4,000. So we know it's going to be more than 19 years because that was 3,500. Something interesting about doubling money in value, you don't even need to know how much money you're dealing with. I'm taking the amount, the 2,000, and I'm doubling it to 4,000. But that's actually not necessary because when I do the next step, I'm going to discover that isolating this is going to turn into 2. Because if the money's been doubled and then I divide by the amount of money to isolate the exponential, then this thing right here is just going to reduce to 2. So doubling it will just end up with a 2 on that side of your problem. Now, of course, we know from earlier that this turned into 1.0025. Again, you can leave that all as is if it doesn't terminate your decimal or become something that's fairly easy to write. So you could just leave the whole thing as 1 plus 0.03 over 12 if needed and work that through the problem. Okay, so at this point we're going to take the log of both sides. Doesn't matter if we do log or natural log, so just for kicks, let's do natural log this time because as long as we use the same logarithm everywhere, it doesn't matter which one it is. We could do any base we want to do. The reason we do base 10 or base e is because those are easy to do in any calculator. Using the power property, I'm moving the exponent to the front again. I'm dividing both sides by the 12 natural log 1.0025. So t is going to look almost exactly like last time. It's just instead of the log of 1.75 on top, I'm going to have the log, or in this case, I decided to do natural log. So either way, just have to be consistent. If I'm using natural logs, I got to stick to it. So log of 2, natural log 2, divided by 12, natural log 1.0025. And the reason it doesn't matter which base of logarithm you use is because this ratio here ends up turning into the right answer as long as you've got the same logarithm both places. So again, I'm going to take this and calculate it. So natural log 2 divided by 12, natural log 1.0025, and I get approximately 23 years. So a little over 23 years to double in value. So the interesting thing about that doubling or tripling is that you don't actually have to have the amount, because if it's doubling, it's going to be a 2 here. When you divide this, the ratio is going to be 2. If it's doubled, it's going to be tripled. The ratio here would be a 3. And so the actual amount doesn't have any effect on that.